I seriously get asked this question every single day by my students, and I'm going to tell you exactly what I tell them every single time, and I am not lying. Step 1, drop the ego. Start with studying concepts that you think that you're too smart to even study. For example, do you know how to calculate a formal charge? Yes, you would be surprised how many people actually don't. Do you know the definition of a bond? Where I would want you to say, well, a bond is made of 2 electrons where each atom contributes 1. Why is this important? Well, when calculating formal charge, which is going to be very important for all your mechanisms in this section of the course, because you have to be able to figure out what the charges of the atoms that are pushing and accepting electrons are in each intermediate along the entire mechanism. Do you know what electronegativity means? What atoms are electronegative, and what does that mean for reactions? Well, it means that they're probably a leaving group. What does it mean to be a good base? Well, good bases are usually good nucleophiles if they're small. Well, what makes a good base? Is a nitrogen a better base than an oxygen? You should know the answer to these things before you try doing very complicated mechanisms. You should also know what makes something acidic. Always argue based on the stability of the conjugate base. Well, what happens if you increase the stability of that conjugate base? Well, it means that you decrease the pKa, so you increase the acidity of the acid form. What does it even mean to be stable? How does the conjugate base even become stable? Well, resonance, induction, the 2 things that you can answer pretty much every single organic chemistry question ever with. And I should be annoying at this point if you've watched my videos, because I say the same things over and over and over again, but I mean it. Know these things, and it will help you attack harder problems. Because I'm going to be honest with you, it doesn't matter how hard you study for this final exam if you are still confused about the fundamentals, because when you get to that test situation and it doesn't look exactly like it did in the notes or the tutorial, you're going to get confused if you don't understand the basics. Something that is also going to be very important for this final exam is knowing the general sequence of a mechanism. For example, mechanisms involving a carbonyl. These mechanisms generally proceed via 3 steps. Step 1 is always nucleophilic attack. Okay, what's a nucleophile? What's an electrophile? Nucleophiles are the things with the electrons, so find an atom with a lone pair. For example, a primary amine. Okay, well, if this is my nucleophile, then who does it attack? Well, it attacks the carbonyl carbon. And shocker, it's usually always the carbonyl carbon or a carbon attached to a halogen. Step 2 is some intermediate state where the oxygen is negatively charged. Step 3 is the leaving group leaves. Well, what's a leaving group? Most likely a halogen or an OMe or an O-ethyl. Da-da-da-da-da. So now what happens if you get through all 3 steps and then you still need to proceed with the mechanism? Well, you go back to step 1. Find a new nucleophile. Make a new transition state. Make a new leaving group leave. Bada bing, bada boom. Final thing I'm going to say for this video is make cue cards with reagents and reactions. We'll do an interactive one right now, okay? On the front of my cue card, I'm going to draw a functional group, let's say some double bond. And then I'm going to subject it to one reagent, let's say H2, PT, and some catalyst, okay? This would be the front of my cue card. Now on the back of my cue card, I'm going to write the product. So what does H2PT do? It rids the double bonds. It's the magician that says, poof, double bonds be gone. So I'm going to draw just propane. That's it. I should be able to answer this question in the forward direction. So now going in the reverse direction, I should look at the back of my cue card and say, I have an alkane. What could this have came from? Let's say I'm doing a retrosynthesis question and I need to introduce functional groups that are not there in the product, but are there in the starting material. I could say, well, 2 carbons that have a single bond between them could also be 2 carbons with a double bond between them. Because I could just subject this double bond to H2PT, and then it would go bada bing, bada boom, goodbye. Yeah. And trust yourself. I swear to God, mechanisms do not lie. The chemistry does not lie. Trust the chemistry. Follow the arrows. Follow the flow of the mechanism. Proceed forwards. I know in a flask, it's not always black and white, reagents to products. But on paper, as a second-year student, we want you to start with something and make something new. That's pretty much it. You've got this. You is smart. But go back to the basics first.